All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, how is it going, guys? Please tell me in the chats if I'm perfectly audible, visible to each and every single student. If you can hear me, if you can see me properly. Okay. Quickly tell me in the chats, everybody out there. If you can hear me, if you can see me, every single thing. And most importantly, guys, smash the like button because liking the session is extremely mandatory. Okay, liking the session is extremely mandatory. I would want you guys to smash it as soon as possible. Okay. So, guys, how is it going? We are starting the new chapter today. That's laws of motion. Okay. So, Wasim sir is having some issues with his studio. Okay, he is having some issues with his screen. So once he fixes that, definitely he's going to take the session. It will take just a day or two. That's for sure. Okay. Yes, I'll be starting from the scratch. And most importantly, if you have not studied this chapter before, if you don't know anything about this chapter, still you would be able to understand each and every single thing. That is my guarantee. Because this channel believes we start each and every single thing from the scratch. Okay. That's great. That's great. That's great. So, my dear friends, let's dive into the session. So, basically, this is the level up session. This is the level up series, laws of motion. We will be starting from the scratch, from the basics. Okay, that's great. That's great. Now, I hope everybody has smashed the like button because liking the session means marking the attendance. Now, guys, first and the foremost thing, when we talk about the laws of motion, like previously in kinematics, you have studied in kinematics when it comes to the chapter kinematics. Okay, guys, let me just give you a basic idea. Okay, in kinematics chapter, we'll be completing rest of the chapters also, like kinematics and other chapters. Right now, let's finish laws of motion. In the chapter kinematics, we spoke about displacement, we spoke about velocity, acceleration. Okay, so all of these things we discuss in the kinematics. But when it comes to the laws of motion, in laws of motion we talk about the forces, cause, dynamics. Okay, so first is kinematics, then you have dynamics. In dynamics you talk about the forces. If we say, sir, velocity of the body is changing, why? It may be because of force. Okay. So, what is the cause behind that change in velocity? That is what we will be discussing in the chapter laws of motion. Now, before starting the laws of motion, the very first thing that we need to understand over here, that is state of rest, and we say state of uniform motion. State of rest, and we say state of uniform motion. Now, my dear friends, when it comes to the state of rest and state of uniform motion, these are the two physical states, okay, that we define in physics: state of rest, state of uniform motion. Now, my dear friends, listen to me very carefully. The very first thing that I need to define over here, let's suppose if you have an object over here and its mass is m. If I say on this object, the force acting from this side is equal to the force acting from this side. Force from both the sides is equal and opposite. Could you please tell me what is going to be the net force on the object? Net force on the object is 0. So if this object is at rest, okay, means it will remain in the rest forever. Okay, yes. Then, my dear friends, state of uniform motion, that means object is moving with constant velocity. So if, my dear friends, I say net force on the object is 0, means force acting from this side is equal to force acting from this side. We say if it was moving with some velocity, we say this velocity is going to remain the same. So we have two physical states. The first one is state of rest and another one is state of uniform motion. State of uniform motion means velocity is constant. If body is moving with 10 meter per second, 10 meter per second, so means this 10 meter per second will remain constant throughout the motion. Okay? Yes. This is how we define the state of rest. Now, my dear friends, listen to me very carefully. Listen to me very carefully. Now, if I say change in the state, if I say change in the state, I would want you to focus exactly over here. So we say there are two states. The first one is state of rest, another is state of uniform motion. Now, my dear friends, when it comes to the rest, if let's suppose there is an object which is exactly at rest, this object is at rest. Okay. Now you can basically change this state to the state of motion. Okay. Okay. And if there is an object which is already in motion, if there is an object which is already in motion, you can make the body at rest. Okay. If the body is in the state of uniform motion, you can make the body at rest. You can either increase its speed or you can decrease its speed. Okay. Okay. Now what I'm trying to say is that if the body, okay, if you want to change the state of a body, you can change. If this is at rest, you can make the body in motion. Okay. If this is already in the state of uniform motion, what can you do? You can make the body at rest. You can increase its speed. You can decrease its speed. This is what we can do in this particular case. Okay. Now, why am I explaining this rest and uniform motion? Because we will have to explain the Newton's first law of motion. Guys, see. This is the first topic that we will be understanding in this one. Take a look. Take a look. So there are two states that we define, state of rest and state of uniform motion. See guys, let's suppose if you have an object over here, this object is at rest. I would want you guys to understand this. If I say force acting from this side is F, force acting from this side is F, what is going to be the net force in this particular case? Net external force in this particular case, that is 0. Now tell me, will it move? Will it change its state? Is it possible that it can come in the state of uniform motion? No, sir. Why? Why? Because net external force is 0. If it is at rest, it will remain in the rest forever. It will remain in the rest forever. Now let's suppose if there is an object, it is moving with constant velocity. Velocity is constant. Okay. We say it will keep on moving forever with the same velocity if net external force acting on the object is 0. So if net external force on the object is 0, we say velocity will remain constant. It will remain in the state of uniform motion always. Okay. 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 Now, my dear friends, one more important point. If let's suppose this is the object, this object is moving in this direction. If force acting from this side is F, force acting from this side is F, we say here also net external force in this particular case is 0. Do you think that it is going to change the direction? No, sir. It will move in the same direction forever. Okay. So basically what I'm trying to say is that if net external force on the object is 0, if it is in the state of rest, it will remain in the state of rest. If it is in the state of uniform motion, moving with constant velocity, it will keep on moving with the same constant velocity. And if it is moving in a proper unique direction, it will keep on moving in the same direction. This is what we call the Newton's first law of motion. So what does Newton's first law of motion say? Take a look. Take a look at the statement. Everybody wants to continue its state of rest or uniform motion. If the body is at rest, it will remain in the state of rest forever. It wants to continue its state unless and until it is acted upon by some external force, unless and until some external force is applied on it. Tell me, guys, is this point crystal and clear? Is this crystal and clear? Tell me. Yes, friction will be also covered in this. Okay, so this is what we call the Newton's first law of motion. Like, if the object is at rest, net external force acting on the object is zero. So this force is equal to this force. We say it remains in the rest forever. It remains in the rest forever. If the object is moving with constant velocity and net external force on the object is zero, it will continue its uniform motion. It will keep on moving with the same velocity forever. Okay. Okay. Yes. I hope Newton's first law of motion is crystalline clear. So what does Newton's first law of motion say? It says that if an object is at rest, it will remain in the rest forever until and unless some external force acts on it. If an object is moving with some constant velocity in a proper direction, and if net external force on it is zero, it will keep on moving with the same velocity in the constant direction forever. This is Newton's first law of motion. Okay. And I told you there are two states of a body, state of rest and state of uniform motion. Okay. Yes. Now, this rest can be changed to motion. Okay. And state of uniform motion can be changed to rest, speed up and speed down. Now, my dear friends, let's talk about the forces. Let's talk about the forces. Let's talk about the forces. See, when it comes to the fundamental forces, we say fundamental forces are, the first one is gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. These are the fundamental forces that we have in physics. And then you have derived forces. These are the forces which have been derived from these. The first one is weight, mg. This weight is actually a gravitational force. Normal reaction, we say tension, we say friction, we say buoyant force, viscous force, spring force. All of these forces are derived from these forces. Okay, now in this particular chapter, we will have to discuss weight. We will have to discuss normal reaction. We will have to discuss tension, friction, okay, and spring force. 1, 2, 3, 4, 5. 5 forces we have to discuss in this particular chapter. Okay. Okay. Now, guys, take a look. First one is weight. Sir, when it comes to the weight, weight means gravitational force. This is a gravitational force. This is, guys, see. Let's suppose this is Earth and you place an object on this. With what force this Earth will attract this mass towards itself? That is what we call the gravitational force. That is what we call the weight. Okay. Like if you have an object on the surface, sir, in the downward direction, is there any force acting? Yes, that is mg. Mg is the force acting in the downward direction. That is weight, gravitational force. So this weight, its unit is Newton. Okay, and this weight we calculated m into g, mass into acceleration due to gravity. This is how we calculate weight. And direction is always towards the center of Earth. Now, guys, see, if you have an object something like this is mass m, and this angle is theta over here. Okay, let me make it on this slide. Let me make it on this slide. Let's suppose this is the mass m. On this mass in the downward direction, we say mg is acting. And if this is theta, if this is mg, we say this would be also theta. If this is theta, this is theta. So this component is going to be mg cos theta. Always remember. And this component here is going to be mg sin theta. I have told you previously. Okay, if theta is from this side, so this component we consider as cos, and this is going to be sine. This will be in the downward direction. This is how we draw weight over here. Okay, this is how we draw weight over here. So what is this weight? If I say, sir, what is the weight on this object? That is m into acceleration due to gravity, mass into acceleration due to gravity, mg. Okay, this is the weight of the object. Now, guys, second one is the normal reaction. We say when two bodies are in contact, they apply a force on each other called normal reaction. Like, see, guys, if you have this hand is in contact with this hand, is there any force between the two? Yes, that is what we call the normal reaction. Like. See, you have got over here, this is a table. Okay, this is a block placed on the table. We say block is in contact with the table. Whenever two bodies come in contact, they apply the normal force. So this table will apply the normal force on this block, that is N. Similarly, in return, this block will apply the normal force on this table, that is N dash. Okay, so I would mention over here, this N is the normal force on the block. And this N dash is the normal force on the table. Okay. Okay. Yes. Is this clear, guys? Tell me in the chats. Yes. And sir, is this normal and this normal equal? Yes. N and N dash will be actually equal. But they are acting on two different bodies. Okay. On this mass, normal is acting in the upward direction. On the table, normal is acting in the downward direction. Okay. Now, guys, here, if you take a look, in this particular case, we say this is the surface, this is the wall. With this wall, there is a block attached, there is a block touched. Okay. Now, my dear friends, you can see this wall is going to apply the normal force on this, and normal force is always perpendicular to the surface. See, it is perpendicular. Here also it is perpendicular. Similarly, this block will also apply the normal force on this wall, that is N dash. Let's suppose you have this question, something like this. Take a look. This is the inclined plane. On this inclined plane, this is mass M. What is the force acting in the downward direction? That is mg. If this is theta, if this is mg, could you please tell me this angle would be also theta? So this is going to be mg cos theta. If this is mg cos theta, this component is going to be mg sin theta. And here you can see this block is in contact with this inclined surface. So on this block in the upward direction, force will be acting, that is normal. Now here. This block is at rest. Block is in the equilibrium. So can I not say this upward force N will be equals to the downward force, that is mg cos theta? Yes, I can say it like this. If the block is at rest, it does not go up, it does not go down. So means upward force will be equals to the downward force. Okay, like here. On this block in the upward direction, we say normal reaction is acting. So this normal reaction will be equals to mg. Upward force is equal to downward force. Upward force is equal to downward force. Okay. And I would mention over here, it's a push-based force. Like. There's a table. On this table, block is there. So this table is pushing this block with the normal force F. It's a push-based force. Similarly, this block will apply the normal force on this table. So this is also push-based force. If the two bodies lose contact, normal force becomes 0. So for normal force, we can actually say there has to be the contact. Tell me guys, is this clear? Now guys, let's take a look in this particular case. Tension force. Take a look. What does tension force actually mean? It is the force which is created in a string. It is a force which is created in a string. Like. Tell me one thing. Let's suppose you have this is a ceiling and this is a rope and there is a block connected to this rope and its mass is m. Could you please tell me, is there any force acting on this mass in the downward direction? Yes, that would be what? Mg. If mg is the force acting on this mass in the downward direction, is this force pulling the mass in the downward direction? Yes, but mass is not going down. Force is acting, but mass is not going down. So means there might be some force in the upward direction. That force is balancing this mg. That is what we call the tension. So we say here tension is equal to mg. This tension is created in a string. This tension is created in a string. So means on this mass, what is the force acting in the downward direction? Mg. So we say still the mass does not go down. Why? Because there might be some force in the upward direction which is balancing this mg, and that force is what we call the tension. And this tension is created in the string. So it is the force which is created in the string. It acts away from the point of contact. Like here. We say this is the point of contact. It is away from the point of contact. Here, this is the point of contact. It is away from the point of contact. This is the tension. Okay. Like if you have this rope over here. Guys. Here tension is T. So we say here tension is T away from. And the same rope is going. So here tension is T. Here tension is T. Okay. If the string is ideal, that is massless, tension at all the points will be same. So we say in case of a same string, we say tension at all the points will be same. Ideal string, massless string. if the string changes, tension changes. See. You have got, this is string 1, and this here is string 2. See, you see string is different, so tension is different. In this string, tension is T1. Okay, here also. In this string, this is another string, tension is going to be T2. Here tension is T. Okay, so tension is T1 and tension is T2. Is this clear? Yes, it will be enough for JEE mains. Is this clear? Is this clear? Let me first finish your basics, okay? These types of forces and all. Then I'll be showing you a lot of questions also. Tell me, is this clear, guys? Now, guys, let's first finish this free body diagram. What does free body diagram actually mean? It means FBD. Now, guys, see, in order to draw FBD, free body diagram, see. What you are supposed to do is, we say, take that body, okay, for which you have to draw the FBD, separate it from the system. You guys are supposed to separate it from the system. Take that body and separate it from the system. Identify all the forces on the body. Okay. Represent all the forces in vector form and then apply the Newton's second law. Take a look. Let's suppose you have got, question is, I would say, draw FBD. Let's suppose you have over here, let's suppose this is 10 kg mass. You have to draw its FBD. First and the foremost thing, my dear friends, you are supposed, in order to draw the FBD, we say, the first point I would mention over here, represent the mass, represent the object with a point mass. Okay. So I can say this is the object over here. Then second point, draw all the forces acting on the body. Draw all the forces acting on the body. Take a look, guys. Force on this in the downward direction, that is going to be 10G, mg. And force on this in the upward direction, that is going to be the tension. This is how you draw. First, you guys are supposed to draw it with a point mass, then draw the forces acting on the body. In the upward direction, it is tension. In the downward direction, it is 10G. So can I say this tension is going to be mg? So this tension is going to be 10G. So G, value of acceleration due to gravity, we take it is 10 meter per second square or 9.8 meter per second square. So 10 into 10 is, we say, sir, 100 Newton in this particular. Let's suppose you are asked to draw the FBD of these two masses. See, guys, I'll write over here FBD of 4 kg. So represent this 4 kg with a point mass. Then draw the forces acting on the body. See. This is 4 kg. In the downward direction, mg is acting, that is 4g. And this T1 is acting, and this T1 is acting. In the upward direction, I would say T2 is acting. In the upward direction, we say T2 is acting. In the downward direction, T1 and 4G is acting. Then I would say FBD. FBD of 2 kg mass. This 2 kg. So we say on this 2 kg mass in the downward direction, 2G is acting. That is 2G is acting. In the upward direction, I would say T1 is acting. T1 and in the downward direction. Now, my dear friends, can I not say this T1 will be equals to 2G? Yes. Upward force is equal to downward force. So that will be equals to 20 Newton because 22 into 10 is 20. G is 10 acceleration due to gravity. Now guys, see, draw the equation over here. Upward force, that is T2, will be equals to the downward force. That will be T1 plus 4G. Okay. So T2 will be equals to T1. Value of T1 is 20 plus 4G. 4 into 10 is 40. So 40 plus 20 is 60. 40 plus 20 is 16. Guys, tell me in the chats, is this clear? Everybody out there? Tell me, guys. Okay. Let's suppose the question is something like this. You guys are supposed to find the tension T1 and T2 and T3. See, guys. So this is 5 kg, 2 kg and 4 kg. One thing, see. Here, this is one string. So tension I mark T1 and T1. And this is another string. So tension here is T2 and T2. Here tension is different, T3 and T3. Let's suppose draw the FBD of 5 kg. FBD of 5 kg. If we draw FBD of 5 kg, so this is 5 kg over here. This is 5 kg over here. In the downward direction, what is the force acting? That is 5G. In the upward direction, what is the force acting? That is T1. So 5G and T1. So can I not say in this particular case, T1 will be equals to 5G. So T1 will be equals to 50. T1 will be equals to the 50. Then my dear friends, let's draw the FBD of 2 kg. FBD of 2 kg mass. If this is 2 kg, we say in the upward direction, tension is going to be T2. This tension. In the downward direction, tension is going to be T1. And in the downward direction, it is going to be 2G, M into G. These are the two forces acting in the downward direction. Now, can I not say in this particular case, guys, upward force, that is T2, will be equals to the downward force, T1 plus 2G. What is the value of T1? That is 50 plus 2G means 20. This is going to be 70 Newton. This is going to be the 70 Newtons. Okay. Similarly, you have got another mass over here. And that is 4 kg. I would say FBD of 4 kg. FBD of 4 kg. So on this 4 kg in the upward direction, T3 is acting. Okay. T3 is acting. And in the downward direction, T2 is acting. And another one, we say mg, that is 4g is acting. Okay. This is 4g is acting. So can I not say this upward force that is going to be T3? It will be equals to that is T2 plus 4g. And that will be, what is the value of T2 that we recently got? 70 plus. What is the value of 4G? That is 40. Okay, that is 110 newtons. How many of you understood this particular question? Please tell me in the chats, everybody out there. Okay, let's move on to the next one. This is a good question actually. Take a look, guys. See, find the normal force between A and B. This is A is 6 kg, B is 2 kg, C is 4 kg. You have to find the normal force between A and B. Let's find the normal force between B and C also. A and B, B and C. Okay, that's cool. See guys, I'll make you understand. First and the foremost thing, on this block, this is applying the normal force. Okay. So this 2 kg will apply the normal force on this. Let's suppose that is N1. N1 is the normal force on 4 kg due to 2 kg. Sir, we have studied if this is applying, let's suppose 10 Newton normal force on this. So this will also apply the same normal force. So on this also, normal force will be N1, but it will be in the opposite direction. Yes. Similarly, this 6 kg block will apply the normal force on 4 kg block. That is going to be N2. This 2 kg will also apply on this 6 kg block. That is going to be N2 same. See guys, on 4 kg, 2 kg is applying the normal force. That is N1. So 2 kg will also apply on 4 kg. That is N1. And 4 kg will also apply on 2 kg. That is N1. Similarly, between these two also there is normal force. Now guys, let's first do one thing. FBD of 4 kg. Let's make the FBD of 4 kg. So this is 4 kg. In the downward direction, it is 4G acting. On this, in the downward direction, 4G. Sir, what about this N1? No, this N1 is on 2 kg. And in the upward direction, it is N1. So clearly, I can say N1 will be equals to 4G. So N1 will be equals to 40 Newton. First, take this upper block. So N1 will be equals to 4G. N1 will be equals to 40 Newton. Then take this next block. FBD of 2 kg. FBD of 2 kg. Take a look at this 2 kg very clearly. On this 2 kg, we said two forces are acting. N1, N2. So N2 is in the upward direction. This is N2. And N1 is in the downward direction. And in the downward direction, we say mg is acting. So that is 2g. Can I apply this N2 will be equals to downward forces as N1 plus we say 2G. What is the value of N1? N1 is 40 plus N1 is 40 plus this is 20. So this will come out to be 60 Newton. Please tell me in the chats if this is crystalline clear. This is 60 Newton. Tell me guys, is this clear? I'll repeat it. I'll repeat it. I'll repeat it. See, guys, see. Take a look in this particular case. This is 4 kg block. On this 4 kg block, listen very carefully. We say this 2 kg is in contact with 4 kg. So this 2 kg will apply N1 on this 4 kg. So this 4 kg will also apply the same normal on this 2 kg. If it is N1, N dash, X, Y, Z, whatever it may be. On this also it is going to be same. Now check these two. This 2 kg is also in contact with 6 kg. So 6 kg will apply another normal on this, that is N2. If this 6 is applying N2 on this, so 2 will also apply N2 on 6, because two bodies apply each and equal forces on each other. Now take this 4 kg block, make its FBD. So this is 4 kg block. What is the force acting on this 4 kg in the upward direction? That is N1. And downward force will be always mg, m into g, that is 4 into g, 4g. So upward force is equal to downward force. N will be equals to 4g, 40 Newton. Then you have this 2 kg block. This 2 kg block. On this 2 kg block in the upward direction, normal force is acting N2. See? And in the downward direction on 2 kg block, N1 is acting. And one force is always there, that is mg. So this will be 2g. 2g is always there. So we say this upward force N2 will be equals to the downward force N1 plus 2g. So that is 40 plus 20, that is going to be 60. Because, is this clear? Is this clear? Tell me. I hope it is now clear, my dear friends. Okay. Yes. Even you can say one more thing over here. What is that? What is that? Guys, see. This 6 kg block is in contact with the surface. So this surface will also apply N3, another normal reaction on this block. Even this block will also apply N3 on the surface. Okay. Now you can even make FBD of, I would say 6 kg. Now on the 6 kg, how many forces are acting? In the upward direction, it is going to be N3. In the upward direction, N3. Okay. And in the downward direction, it is N2. This N2 is in the downward direction. N3 is in the upward direction. And mg will be also in the downward direction. Okay. So I would say this is going to be 6g mg, because its mass is 6. Now upward force N3 will be equals to the downward force, that is N2 plus 6g. Now what is going to be N2 in this particular case? N2 is 60 plus 6 into g is 60. So 60 plus 60 is 120 Newton. So N3. Now I have calculated all the normal reactions, okay, which are acting in this particular case. Which are acting in this particular case. Okay. Now guys, take a look at this question. This is a very good question. Find the tension and angle theta made by the spring if the system is in the equilibrium. If the system is in the equilibrium. Find the tension and angle theta made by the string if the system is in the equilibrium. system is in the equilibrium. When I say equilibrium, it means net force on the system is zero. It means net force on the system is zero. If net force on a system is zero, it means the system is in the equilibrium. Okay. Now guys, see. We say in this particular case, take a look. There is a force which is pulling the mass in this direction, and this is a rope. We know, sir, in the rope will be one force which will be acting, that is tension T. That is tension T. If this is tension T, okay, this is tension T. Could you please tell me, sir, if this is theta, listen to me very carefully, this angle would be also theta. If this is T, this is theta, this is going to be T cos of theta. And this component is going to be T sine of theta. T cos, T sine. And this is F. In the downward direction, it is going to be mg. In the downward direction, it is going to be. Okay. Now, guys, take a look. Upward force T cos theta, downward force mg. Left side force T sine theta, this would be F. If the body is in equilibrium. If the body is in equilibrium. What does that mean? That means net force is zero. Net force is zero means upward force is equal to downward force. Left side force is equal to right side force. So left side force will be equals to T sine theta. It will be equals to F. Upward force will be equals to downward force. So that is T cos theta will be equals to mg. T cos theta will be equals to mg. Okay. Now divide the two equations. Divide the two equations. Divide the two equations. If you divide the two equations, what can we say? T sine of theta divided by T cos of theta. It is going to be F divided by mg. So T and T will cancel. Sine theta by cos theta, it is going to be tan theta. Tan theta is going to be F divided by mg. And this theta will come out to be, if you take this tan over here, it will be tan inverse of F divided by m. Tan inverse of F divided by m. You were supposed to find angle theta. Now you can find the tension also. So this is the tension, this is the theta. You can find the tension also. See, let's suppose this is the same mass that we have over here. This is the same mass that we have over here. What are the actual forces acting on the mass? We say actual force is this F, and then this is mg, and in this direction it is going to be tension. Don't resolve tension now. Now guys, tell me one thing. If you have two forces, two vectors, and I say resultant of this and this will be in this direction, this is going to be the resultant, that is R. And always remember, if angle between the two vectors is 90, their resultant is going to be under root of this force square plus this mg square. This force square plus this mg. So basically, if this mass is having two forces, this F and mg, resultant of F and mg will be under root of F square plus mg. Now take a look. Now guys, this is mass m. If you have calculated the resultant of this F and mg, that is this R, in the upward direction, it is going to be this tension T. Don't you think that the body is in the equilibrium? Upward force will be equals to downward force. So T will be equals to R, and that is going to be under root of F square plus we say mg whole square. F square plus mg whole square. So this is going to be the resultant in this case. This is the tension acting on the mass m. So we were supposed to calculate tension and theta. So theta we got tan inverse of F divided by mg, and this resultant, this tension is under root of F square plus mg whole square. Tell me guys, is this clear? Let's suppose you have this question. Tell me the answer of this question. If the system is in the equilibrium, then find the value of m. You have got two bodies. This is m, this is 4 kg mass. Guys, one thing, this component here is going to, this will be mg acting in the downward direction. And if this is 30, this will be also 30. Okay. And this component is going to be mg cos 30. And this component is going to be mg sin 30. This is mg cos 30, this is mg sin 30. And here in this, it is going to be tension in the downward direction. It is going to be 4g. Okay. Yes. And guys, this is the rope over here. This will be the tension T. Now guys, see. First make the FBD of 4 kg. FBD of 4 kg. So this is 4 kg. In the downward direction, it is 4g. In the upward direction, you can say this is tension. Can I not say this system is in the equilibrium? Upward force will be equals to the downward force. T will be equals to 4g. So this T will be equals to 40 Newton. So tension is 40 Newton. Now make the FBD of this block. FBD of what is this block? That is M. Now guys, take a look. This is M. Listen carefully. On this M, in this direction, it is mg sin 30. Something like this. mg sin 30. And in this direction, this is going to be tension T. So here you can clearly say T will be equals to mg sin of 30. T will be equals to mg sin 30. Now tell me, can I not say this T you recently got, that is 40, is equal to m. G is 10. Sin 30 means 1 by 2. So 2 1s are, 2 5s are 10. So m will come out to be equals to 40 divided by 5. That is 8 kg. Tell me in the chats, is this crystal clear to each and every single student? Yes. Let's take a look at this question. Find the relation between M1 and M2 so that the system is in the equilibrium. Okay. Find the relation between M1 and M2 so that the system is in the equilibrium. See guys, this angle is 30, this is 60. This is M1 and this is M2. So tension will be acting T. Here also same tension T because it's the same string. In the downward direction, it is M1G, M1G, M1 into G. And on this in the downward direction, it is going to be M2 into G. If it is M1G, this is 30. This component would be what? M1G cos of 30. Because if this is theta, this is theta. Okay, we won't be showing you this one. We say this component is going to be mg sin 30. M1G sin 30. This is M2G. This component is going to be M2G sin 60. Okay. So we say the component along this inclined plane, that is mg sin. Now, don't you think FBD of M1, this is M1. In this direction, it is T1. It is T, not T1, it is T. Sorry. Take a look. This is M1G. And in this, it will be M1G sin of 30. And here, this is tension T. This will be M2G. In this direction, it will be m2g sine of 60. And here it is tension T. Now, make this FBD of m1. In this direction, it is T. In this direction, it is m1g sine of 30. So here I can say T1 will be equals to, or T will be equals to. Why am I mentioning T1 again and again? So T will be equals to m1g sine of 30. And when you talk about this m2 mass, in this direction it is m2g sine of 60, and in this direction it is T. So here T will be equals to m2g sine of 60. Now guys, see, so here T is equal to this, here T is equal to this. So can I not say from first and second, m1g sine of 30 will be equals to m2g sine of 60? Yes, g and g will cancel. So this will be m1 sine 30 is 1 by 2. m2 sine 60 is root 3 by 2. 2 and 2 will cancel. m1 will be equals to root 3 times of m2. Is this clear? So that's all for today, boys and girls. Thank you so much. See you in the next part. So this was the part first. See you in the next part. Till then, bye-bye and take care. I hope you liked the session. Please do let me know in the comments. Once I end the live stream, do let me know in the comments how was the session. Did you like it or not? Okay, I'll be waiting for your comments. So take care. God bless you all. Thank you so much. Have a great day. Okay, take care.